Welcome, my friends. Sit down and lend me your ears because it's story time. This one's about astronomy. It's about supermassive black hole M87, or M87, as I call it. Um, when I did this story in class, one of the students said, "Oh, that's the name of a song." To which I said, "Yes, it's on there, on Muse's later space rock albums, but I do prefer the first two." And at the time, I couldn't remember the name of the album, but it turns out it's Black Holes and Revelations, which is exactly what this story is about, as we'll see. All right, Mate 7, it's very far away, 55 million light years. It's 6.5 billion times the mass of the sun. The sun is 330,000 times the mass of the Earth, and the Earth is 5 million billion kilograms. That is 5 and 24 zeros. So it's very massive, and it's in fact it's so massive that its gravity makes a whole galaxy spin around it. This galaxy Messier 87. This is what it looks like. The old glowy blurry donut. It does look like a halo. So it's black hole sucks in matter and even light, and it bends the very fabric of space-time around it. So we're seeing the gravitational lensing and the glowing stuff. That's the accretion disk. So what we don't see the black hole itself because by definition you can't. There's no light coming out of it. But we do see the matter that is falling into it. It's very much like when you empty your bathtub and it circles around the drain. But this isn't a story about the black hole as much as it is the revelation. This was the first image we got of any black hole ever, right? We knew they existed because they were predicted by our standard models of gravity, although those can't seem to explain about 90% of the matter in the universe, but those are the best ones we have. Um, and we knew that like galaxies would revolve around it, and we knew the theory, but we've never actually observed one. And that came out in 2019. It's very underwhelming. It's quite disappointing compared to what we imagined black holes to be, or even how they have been rendered based on the physics of it. They are rendered in some video games, like I think No Man's Sky has got some, and the Elite Dangerous remake also has some. So that's kind of disappointing, underwhelming in comparison, but not what when you know what is involved, right? Because from Earth, Mate 7 is very, very tiny, right? As big as an orange on the surface of the moon, and one pixel of the best telescope's pictures would fit 1.5 million oranges on the surface of the moon, right? Um, and yet we got this picture. How? With science. All right. We start with arrays of radio telescopes. Those are put in high altitudes. This is one on a mountaintop volcano, but most probably in Hawaii. We put them far up so that there's not so that there's not that much atmosphere between them and space, because atmospheres is what makes the stars twinkle, right? It's disruption. And we take those individual arrays and we combine them, and that gives us, if we can combine them in the right way, it all behaves as if it was one giant telescope. In fact, those are radio telescopes, which are like regular optical telescopes. Light is just a the electromagnetic wave, right? So radio telescopes looks like a big satellite dish, but they come in arrays. Same principle where we put the individuals together to make like a big, massive satellite dish, and then we put those arrays together. This is what they've done for the black hole, and it looks like an Earth-sized satellite dish. And suddenly, our satellite dish, our telescope, is big enough to be able to see the picture of Mate 7 that is so far away and so tiny in the sky. But to combine all of those images, you need an algorithm. This is Dr. Katie Booman. She worked on the team that wrote the algorithm. She's always very keen to explain it was a team effort, but uh, because of the picture I'm going to show you in a second, we think of her as having written the algorithm. Um, and that revealed Mate 7 to us. And she's here posing with some of the hard drives involved in the project. This is just how much data there is. And she came to fame not because of this picture, but because of this one. This is the first time anyone on Earth ever gets to see a black hole. Katie has run her code on the right side of the screen, which is Python, by the way, and then it works. And then she sees the black hole, and look at the joy on her face. And this is why I'm telling the story in class, because I want to explain that coding is a lot of effort. It requires a lot of persistence. It's extremely frustrating. The computers want every single, parenthesis and colon to be just right. But when it does work, it brings you so much joy. Takeaways from the story: uh, when we work together, right, we achieve more, like telescopes. But also, programming is not just for programmers. Now you can't spell STEM without CS. The actual letters, notwithstanding, right? Whether it's astronomy, physics, biology, even economics, epidemiology, clearly, right? Medicine, you need to be able to, the moment you need to handle large amounts of data, and turn it into information and hopefully knowledge, you need code. And in fact, Python actually is everywhere. So it's not. It is astounding to us older computer scientists that the language we teach with and we learn with can be the same as the one that powers, say, Instagram, the instant telegram, or 80% of Spotify, or the recommendation algorithms of Netflix. It used to be that programming languages were very different. There was Basic, aptly named, and Logo and Pascal when you started, and then maybe C and C++ elsewhere in production. So it really surprises us, but I don't think that young people that come to programming straight to Python, in the 21st century, are as impressed by that. But still, from Turing Lab and learning to revealing black holes via Instagram, Spotify, Netflix, Python is everywhere. But that which speaks highly to its elegance and its simplicity and its understandability by people that may not be like actual software developers, right, professionals, but just do need to program. But other languages are available. Thank you for watching. This was this week's story time.